Welcome to Quid Pros Quo, where creativity meets academia. Here, we're all about leveraging our love of academia to improve both your creative writing practice and ours. Whether you're honing your craft or just beginning your writing journey, we're here to share scholarly insights, inspiration, and advice that benefits us all. Let's get started. Hi, welcome to Quid Pros Quo. I'm Rin.
And I'm Zach.
And today we are continuing our Planetary Science for World Building course.
Amazing. If this is your first time joining us, since we've switched to our course-based podcast, first of all, welcome. But let's also give you a little bit of background about what's going on. This year, we are packaging our episodes in courses about a specific topic related to writing, science fiction, fantasy, as well as the business of being an author. And the way that these episodes are set up is that we include some information about a topic of interest to authors, and then we provide some insights into how you can use it inside of your writing, finishing up with a bit of homework. And we are hoping to read some homework submissions at the top of our episodes. So if you are interested in having your work read on the show, please send us your responses to the homework at quidprosquo@gmail.com, and we'd love to give it a read.
Yeah, we are so excited about the homework and having you guys be more involved with the show. I think it'll be really awesome. So in this episode of Planetary Science for World Building, we're exploring what planetary science can tell us about satellites. Broadly defined, satellites are the things that orbit planets, and we'll put them into two broad categories, which are moons and rings. First, a disclaimer. Even though we have been able to detect thousands of exoplanets in the past 30 years, we haven't been able to confirm the existence of moons around planets outside the solar system, which are those exoplanets.
Yeah. It would be really, really strange for our solar system to be like the only thing in the universe that has moons. So we're pretty sure that there are other moons out there. We just haven't been able to find them yet because they're so small. And even though our telescopes are really big, they are not big enough for us to be able to detect those exoplanets. In the process of doing some research for the show today, I found a couple of articles about the saga of potential discoveries of exomoons, and then later finding out that they were, data anomalies are caused by something else. So we're still waiting on those first exomoons. So today we are going to be talking about the moons that we can observe in the solar system, and there are a lot of those. In case you've been living under a rock and have never seen it, Earth has one moon. It's a really big and beautiful moon.
I think we're all living under the rock because the moon is the rock.
True.
So if you were living under a second smaller rock, anyway, sorry, keep going.
Speaking of smaller rocks, Mars has 2 moons, and both of them are much smaller than our moon. At the current count, Jupiter has 95. Saturn has 146 moons. Neptune has 16. Uranus has 28. And Pluto, our favorite dwarf planet, has 5. And that's not counting moons around other dwarf planets like Haumea.
The solar system also has 4 ring systems we can look at, one on each of the giant planets. So what can we learn from the examples we have in our solar system? First, satellites come in a lot of different shapes and sizes. Large moons are spherical for the same reason the planets are spherical. Gravity compacts them, like gravity being the force that pulls all in equal force, equal directions.
Yep.
So that's why we get spheres. Small moons can be potato-shaped because their gravity isn't strong enough to compact them down into spheres, which is something cool. I didn't know that before this episode.
Yeah, so when you have a really, really small planet, you have structure inside of when you have a really, really small moon. I said planet before, but we're talking about moons. When you have a really, really small moon, there are structures inside of the moon that press up against gravity, and when you don't have a lot of mass, there isn't a lot to pull in on itself in order to make it a sphere. So if you look at images of some of the moons, like Mars's moons, Pluto's moons, some of the really minor moons of Jupiter, they all looked like potatoes just tumbling through space because they're small.
That's so fun. I love that. As for the composition of moons, moons can be rocky or icy, and they can have lots of different environments on them. For example, the moon and Ganymede are both rocky moons without atmospheres. Io is a highly volcanic moon that belches material into space. Enceladus, is that how you say it? Or
And
Enceladus?
I've heard Enceladus, I've heard Enceladus as well. I think you can
Okay.
kind of pick how you want to pronounce it.
Cool, we love that. Enceladus and Europa may harbor huge oceans underneath their surfaces. And Titan is a moon with a fully fledged liquid nitrogen cycle. There's a lot of the same things a wilder cycle does on Earth.
So there are
So,
lots of different options for you to play with inside of your world building. It doesn't just have to be a bare, rocky moon like we have on Earth.
let's talk about how moons form next. There's two ways we get moons. First, the capture of asteroids and comets and accretion, which is when bits of gas and dust stick together like a snowball does when you roll it through a field. And that's our current best model for how planets are formed too, is the accretion model. Earth's moon is probably the result of a collision between two protoplanets and the subsequent reformation of the two into spherical bodies. So, if I understand this correctly from my minimal astrophysics experience, is there to the two protoplanets and one formed Earth and one formed the moon, right? That's how I
Yeah.
think. Okay.
So we think that we got proto Earth and we have this other protoplanet called Theia. And what we think happened is that Thea ran into the Earth and just kind of blew out a whole bunch of stuff all over the place. And with time, all of that stuff formed itself into the moon and into the Earth. The reason why we think that is because the moon has a really high iron content, which makes us think that it came from deeper inside of the Earth and scooped up a whole bunch of iron out of there and put it out um, into space. So, moon, like the relationship in between the Earth and the moon is really unique. We have one of the largest moons in comparison to the mass of, in fact, I think it is the largest moon in comparison to the mass of the host. Most moons are a lot smaller than their host planets. Um, but there are also other options. We think Mars's moons are captured asteroids. That's part of the reason why they're all lumpy and potato shaped. And Jupiter probably has a bit of both. Some likely formed orbiting the planet via accretion, while others were likely captured. These two formation mechanisms are like a helpful segue to talk a little bit about a fancy astronomy word, which is inclination. Inclination is a word that basically describes how tilted the orbit of a moon is, usually with respect to the equator of the planet that they're orbiting. And it turns out that moons that form in space tend to have really low inclination. So the moon, like our Earth's moon, is pretty darn close to the Earth's equator, and that is often the case for lots of other moons. But if you're looking at more asteroid-like moons, those ones can be more tilted than others.
That makes sense. So, capturing a moon, which captured moons have wildly different inclination angles, is difficult. You remember last year there's a bit of a hubbub about Earth getting a mini moon for a short while? What was going on there was that you had an asteroid that fell into the Earth's gravitational sphere of influence, which caused it to spin around the Earth, which is why we called it a mini moon, because it was orbiting the Earth. But it was moving fast enough that it could still escape the Earth's influence. If it had been moving slower, we may have ended up with a second moon, which would have been like so cool. Imagine living through that like historical event. Not that we aren't already living through so many historical events.
This would be an astronomical historical event, which
Yeah.
there are lots of fun ones of those too. Maybe we'll talk about them at some point on the show, because that's my world. That's what I do.
For sure.
That's where I am.
Nice. So from that, like that hubbub about getting the mini moon, we learned that it's not enough for an object to fall into the Earth's gravitational influence. The object also has to be going slow enough.
Yeah. So if it falls in and it's slow, then you might get a second moon. That's how you capture them. Once you have the moons, they are going to have some kind of impact on the planet. moons exert gravitational forces on their hosts, just like the planets do on their moons. That's the whole Newton's third law thing. If a moon is big enough, it will draw the center of rotation in between the moon and its host planet out from the bigger planet to somewhere in space between them. Um, Scientists sometimes call these binary planets, just like we talked about binary stars inside of our last episode. These have been theorized to exist, though, as far as I know, they have never been observed. So, another thing that we're looking for out there inside of the universe, which would be super cool, super duper cool. Just like we mentioned in the last episode when we were talking about stars, moons make tides on the things that they are orbiting. Just as a quick refresher, tides are caused by the difference in the gravitational force felt by the near side of the object compared to the far side of the object. And what this does is that it means that the host planet gets squished a little bit by the increased amount of gravitational pull on the near side and the less amount on the far side. And this is what causes the high tide and the low tide for the Earth.
If a planet has multiple large moons, you would sell you would have multiple tides, one set for each moon. And it's also important to note the small moons still make tides, but they may not be as noticeable as those of a bigger moon.
Yeah.
So the tides can interfere with each other, and then I'm sure you get into so many fun wave physics and dynamics, but we're not going to get into that right now. Tides also mean that the rotation of moons and planets tend to equalize, which essentially means that tides drag on the moon and the planet until the same sides is facing each other all the time. So, and this way it's called being tidally locked, right?
Yeah, exactly.
And our moon already has one side that always faces us. If you ran the clock long enough, the Earth would always face the moon, and only one side would ever be able to see it, which is crazy.
Yeah, isn't it? The thought that only one side of the Earth would be able to see the moon, ever.
Yeah, I'm just thinking of how that would become a huge tourist attraction for half the Earth. Which is a really cool world building idea, is a world that only has the moon visible from one side of the planet, so it's a big deal to be able to go and see the moon.
Yeah, it kind of feels almost like a science fiction version of a Tangled setup where it's oh, I just want to go see the moon once.
Oh, you're so right. That would be so good. I would eat that up. I love anything with Tangled.
Take note. We're throwing out ideas for free here.
We're giving you free ideas. Okay, Zach, do you want to talk about rings next?
I would love to talk about rings. Rings are made of bits of gas and dust that haven't accreted into moons. And why haven't they accreted into moons? Sometimes it's because there just hasn't been enough time yet. So if a planet is really young, it might have rings that are in the process of becoming a moon. But the other reason is because if you have material that's close enough to the planet, then the tides that the planet exerts on any potential satellite are stronger than the forces holding the satellite together. The fancy word for this inside of astronomy speak is the Roche limit, named after the scientist who did all the math in order to give us the actual okay, here it is. It's too close. Now it turns into dust all over the place. So what that means is that moons are located somewhere between the Roche limit and the edge of the planet's gravitational influence. So if you have a planet that has both rings and moons, you will have the rings closer to the planet than the moons, which is something that we see with the gas giants.
You can also have rings that are caused by moons shedding the material as they go around their orbits. If you have a highly volcanic moon like Io, which is one of the moons of Jupiter, it will make a ring out of the stuff it has thrown off the moon. These rings probably won't be visible, though.
Just a little tidbit.
Which is also so fun.
Yeah.
Rings tend to be aligned with the equator of the planet they orbit, meaning their view from the rings will depend on your latitude. So higher latitudes correspond to the rings being more visible in the sky, but if you were at the equator, you would look up and just see a thin ring, versus a higher latitude would be more of a band in the sky.
Yeah. There are some really cool images out on the internet where people have shown what the night sky would look like on Earth if we had a set of rings. So if you're trying to picture kind of what this looks like, you should go find your favorite search engine. Mine's DuckDuckGo. Go find those images. They're really great references that you can use if you want to slap rings on your planet.
Yeah, super cool. Um, Also, depending on how much the planet is inclined, that could lead to the sun being covered by the rings during certain times of the day or certain times of the year. And the planet will also cast a shadow on the ring system, so the rings usually won't be completely visible at night. And I'm sure the art that Zach is talking about has like all these scenarios, so you can see kind of what it looks like at different times of the day too.
Yeah, it's been a while, but most of the images that I have inside of my mind right now were during the daytime, but I do think there was at least one that was nighttime. So we'll have to look it up. Maybe we'll put a link inside of the show notes when we're done here.
Excellent.
So, as far as we know, for a moon to be habitable, it has to have water. And if it's going to have water on its surface, it needs an atmosphere. The problem is, most moons are too small to hold on to an atmosphere. But there's nothing that says that you can't have an Earth sized moon around a gas giant that is massive enough to hold on to an atmosphere, though. There are other ways of getting around this. There are quite a few moons that we suspect have liquid water underneath their surfaces. And so, if you can't have water on the surface, you just put it underground. There are kind of two mechanisms that lead to this situation with subterranean water. The first one is when you have a really large moon. As the moon forms, it gets really hot. And when it gets really hot, it starts to separate out into layers in the same way that your like salad dressing inside of the fridge will separate out into the oil and then the rest of the stuff if you leave it for too long and don't touch it. And so one of the layers that can form inside of a case like that is water. And that's what we think is going on with Ganymede. The other way that we get subterranean water is through tides on acting on an icy moon. These tides need the moon kind of like a ball of bread dough, and that makes the interior get hot, and then the inside melts, and you got a liquid ocean underneath there. As a astronomy side note, this is one of those newsworthy things inside of the world of astronomy that makes me excited. Um, we meaning humanity just launched the Europa Clipper last year, and it's a spacecraft that's meant to tell us more about the inside of Europa, because we think that there's liquid water there, and if there's liquid water, maybe there's life there. Even if there's not, there's still a lot to be learned about the universe from looking at Europa.
So if there's life there, is that just referring to bacterial life, or do we think it's like fish-esque things? Like, what do we mean when we say there might be life under the surface of a planet or a moon like Europa?
Well, I have to be careful because I'm not an expert on this, and I do
Yeah.
know I have some contacts inside of astronomy who are really who get really frustrated when people overhype the aliens.
Mm,
So what I'll say is that it depends a lot on who you talk to,
okay.
because what it comes down to is that we've never looked inside of Europa's oceans, so we don't really know what we might expect there. Um, I would say that on the scale of like complexity of life, it's most likely that if we were to find life, it would probably be microbial life. But then that
Okay.
asks the question, like, how would we detect that kind of thing? We'd probably have to take like a water sample or something to be able to see that it's there.
Yeah.
Um, so the Europa Clipper in and of itself is, has um, a limited ability to actually answer the question directly: is there life or isn't there um, on Europa? That's not to say that it's completely impossible that there are like fish on Europa. Like that's definitely a possibility. I would just say it's probably a smaller one than microbial life.
For sure, that makes sense. I was just wondering if we thought there could be like alien fish. I think that would be fun if the first fish we found, if the first aliens we found were fish. Like, and I
Amazing.
just think it'll be so interesting because fish is like also not, as a biologist, fish is not an actual classification. Like,
It's like the grab bag, right? You just put everything into there
yeah,
that's like in the
you're
water.
like, oh, aquatic species vertebrates, fish. And I'm not an ichthyologist, so I don't know much more than that. I just remember I had an ichthyologist professor, and he was like, "Fish aren't real." And I was like, "That's so valid, bestie." But anyways, one more bonus tidbit is theoretically possible for a moon to have a moon. It would just have to be close enough to the original moon for its gravity to matter more than its host. It would also have to be much smaller than the main moon to avoid being pulled out of orbit of that main moon. So there's a couple layers there.
Yeah, so if you have like the host planet and then a moon, then the moon can have a moon. And this is so delightful. They're called moons.
You're joking. I love that.
They're so like it just sounds so cute. I have never heard of them being observed, but it's just one of those theoretical things that is so fun and delightful, and I just love them. So you have the moon needing to be close enough to the moon for the moon's gravity to matter more than the host planet. That's how that goes if I were to remove all of the pronouns that I put in there on the first draft.
Mm.
When I was, putting this together, I was like, well, if there's such a thing as a moon, then maybe there are ringed moons too. Like, so, but I would presume that a moon would have a Roche limit. I haven't actually like cranked out the numbers to look at it, so maybe I'll do that too and write up a little Substack post and post it so that people can read it. But that's besides the point. Let's talk about what you can do with this information for your world building. First and foremost, you can play with the size of your moons and your distance to them. The further away a moon is, generally, the slower it will orbit the planet. You could also go the other route and have the moon really close. So, as an example, both of Mars's moons orbit really quickly. One orbits every 8 hours, while the other one orbits once every, round about 3 days, which would have big impacts on how time is kept inside of your world and what sorts of denominations of time would exist. Like, if we had a moon that was zipping around the Earth once every 8 hours, would we even have an hour, or would we just call that revolution a unit of time?
Yeah, that's so cool. You could also have multiple moons, like Brandon Sanderson's Trust of the Emerald Sea. And remember, if you're writing harder sci-fi, having multiple moons will mean that the nearest one will appear the biggest in the sky, since you will have large distances between the moons to prevent them from smashing into each other. The furthest moons might just look like really quickly moving stars.
So kind of like the way that the planets look inside of the sky in the solar system, because you can see the planets moving a lot faster than the rest of the stars do.
So cool. If you have multiple moons, you can play with having the moons eclipse each other or being misaligned. And we know eclipses can have lots of cool world building things because they've had cool world building things in our own world. You can also play with the kinds of moons you have. Maybe you have a big cloudy one, a volcanic moon, or an icy moon rather than a rocky one.
Yeah, and if you have a volcanic moon, maybe you can have the volcanoes like throwing material down onto the surface that people can go and recover. You could also have the moons rotating to show different faces at different times. If you really wanted to go into the weeds, you could do something about the face of the moon that's showing to factor into an astrological fortune-telling tradition. And this is where I'm going to put in my obligatory disclaimer that astrology is not a science and is not related to astronomy, even though they sound really
so important. That is a very important distinction. I can't believe we didn't make that in the first episode.
I know, right?
For sure.
Oversight.
Someone is going to look at our planetary science system and like, why are they talking about astrology on Quid Pro Quo? And this is not what we're doing. So, additionally, maybe your planet has become tidally locked to its moon, so maybe only one side can see it, which means maybe less astrological implications, but other fun implications. Like, there's lots of stuff you can do with it.
On the topic of interesting things that can happen with moons, maybe your planet captures a moon. If you're familiar with the Broken Earth trilogy by N.K. Jemisin, there's a bit about capturing versus not capturing a moon inside of the later two books, which is really interesting. We talked about slapping rings on your planet. That's super cool. And you can mix and match with a ring and some moons if you want.
Nice. So your homework for this week, using some of the information we provided here, come up with your own moon planet system. Then write a little about A, what kind of stories are attached to your system, or B, how this system impacts timekeeping and or superstition. This is a really fun homework episode, one that I will probably be putting up on my Substack. So check it out. It should be good.
Yeah, we're excited to see your work.
Yeah, send it to us. Our email is quidprosquo@gmail.com. You can leave it in the comments on whatever platform you're listening to. If it allows comments, we'll do our best to check those platform comments. I've said platform comments too many times now, and it's not a real phrase anymore. Anyways, this has been Quid Pros Quo. Thank you so much for listening. We'll see you next week.
Quid Pros Quo is hosted by DC Winters and CK Jensen. If you liked this episode, please subscribe and leave us a rating on Spotify, Apple Podcasts, or wherever you get your podcasts. If you'd like to contact us, you can email us at quidprosquo@gmail.com. Thank you for joining us today.